This time on openFrameworks superBasics, we're building interactive 3D meshes, distorting them with Perlin Noise, rendering them as point clouds and as wireframe, learning about how to animate them in real time and colorize them, and just doing just more crazy generative weirdness. openFrameworks superBasics. That'll do. openFrameworks superBasics. Last time we looked at moving into 3D. We built random box clouds using openFrameworks 3D primitives. So this is things like saying, please make me a cube, make me a sphere, make me a cone, make me a flat plane. These are made of meshes of points that are joined together to make surfaces, added lots and lots of triangles, 3D style. In openFrameworks, we can build meshes by hand if we want and manipulate all of these points in meshes to do all kinds of things beyond moving around just basic primitive shapes like we saw last time. And in this session, that's what we're going to do. We're going to build some meshes, we're going to manipulate them live using randomness and also Perlin Noise, which is a kind of streaky, lumpy, smooth randomness. I've built a new openFrameworks project, and I've set up a couple of things in the project because there's quite a lot of code, but we're going to step through it piece by piece. And I'm starting in the header file as usual, and I have made two things. I have made an ofMesh object. And this is one of the things that underpins all of these 3D primitives. And it allows us to build a mesh by hand. And it's an object that we can put points into to say, make a point in space here, and a point in space here, and a point in space here, and join them all together. So I've made a mesh, an ofMesh object called MainMesh. And like we saw last time, I'm using the EasyCam object, which allows us to look around in the 3D scene. And when we view it by switching on or enabling the camera, it shows us our openFrameworks scene in 3D. And then all I've added to that is a pair of integers for width and height, which is the width and the height of the mesh that we're going to make. So we specify points in space, and each point has an X and a Y and a Z coordinate for each point. If we want to turn this into a surface that we could put images on, we could color, we could have light reflect off of and stuff like that, we need to describe the surface. And generally, we're going to build things out of triangles. You can make things out of quads, 4 points, but we're going to make them out of triangles in this instance. So what we need to do is specify one point links to another. So if we say this is point 0, point 1, point 2, point 3, we'll point 0 to point 1. And then if this is 1, 0 for our second line, we then specify that this point 1 goes to point 1 here, and then goes to point 0 there to make a triangle. So we make a right-hand triangle, and then we'd also make a left-hand triangle. So we'd say point 0 goes down to point 1, goes across to point 0 here, goes up there. So we have a left-hand and a right-hand triangle. And this gives us a surface, a plane. So what we're going to do is we're going to build a series of these dots in space, and then we're going to specify all the left-hand triangles and our right-hand triangles. And if you notice, as I've been drawing these, I've been drawing them in a particular direction. And sometimes, and this is getting onto more complicated stuff, people talk about the winding of how these surfaces are made on the points. And I've been going always clockwise. Often, different 3D programs will decide upon which is the front and which is the back of a surface, depending upon how you join the dots together, these vertices, to make the surface. So generally I'm going with right-hand winding, which is sort of clockwise. So I'm going to describe all these points and put them into my mesh object as vertices. And then once I've got them all, I'm going to go through and say, join point 0 to point 1, to point 1, 1, to point 0, and on and on and on, a loop through to make my mesh. And once I've got it in my mesh object, I can do whatever I like with it, including going back and changing the coordinates and position of these points. And given that I've described how point 0 and point 1 and point 0,1 join together, if I move the points, that relationship stays. So that triangle starts to change shape. So I can manipulate my mesh and still have it surfaced. Coming back to my code, I've made my ofMesh object, and I've called it MainMesh, and I can make lots and lots of these. And I've made a new EasyCam called MainCam, and I've set up an integer with width and height, and this is how many points across and how many points down I want to be in my two-dimensional or my flat plane mesh. And in my CPP header file, I've again used of enable depth test. And then my integers width and height, I just said width equals 50, height equals 50. I've set my background to 0 to be black and my drawing color to be white. And I've just set MainCam set position to be 0x, 0y, and back off in the Z direction. So it's x, y, z, these 3 dimensions for the camera position. And I've said just back off 80 pixels or 80 units to look at my scene from above. And then I'm going to make a loop. Inside my inner loop, I've got one loop inside another. So I'm going to loop from x equals 0 to the width, which we set as 50. And then I'm going to loop down and across using y equals 0. I'm going to use MainMesh add vertex, which basically says take this mesh object that we made just now and put a new point in it. And it just sees them as a long line. So I can say, go and find me on the position of point 1, point 19, point 5000 as this list of vertices. And it's expecting an x, y, z point to be put in there. So 3 values. So I'm saying MainMesh add vertex, and then I'm going to make an OF point object. And the new vec3 is the thing, but this is a way of making an XYZ point. And I'm going to say the X part is going to be X minus the width divided by 2. So as we go across, the middle of the line is going to be at 0. And then as we go down, the Y is going to be the height divided by 2. And then the Z value at the end here is going to be 0. So it's all going to appear flat in front of me at 0 on the Z plane. And I just loop through adding these. And what I can do is I can set the color of each of these vertices as I add them, which I'm going to do because we're going to play around with the color later on of all these dots, because we can make a mesh with different colors at different points. And the simplest way to add is to say MainMesh add color, and it'll add color at this particular vertex that we've just made or we're making. I'm in my draw routine, I'm just going to say MainCam begin, so it starts using the EasyCam 3D so I can drag with the mouse or the trackpad to have a look around inside my 3D world. And then I can say MainMesh dot draw, and I can draw the faces or a wireframe, and in this instance I want to draw the vertices, and then I just end the MainCam and switch it off. So I've just made all of these dots in the mesh object and put them in as vertices, and I'm just saying draw me the dots. Down at the bottom here, I'm making a new string object called message, and I'm putting a load of debug text in it just to remind me. So this will just print to the screen, and then I'm using of draw bitmap string, draw me the MSG or message string at 10 pixels across and 20 pixels down. Done. So it's going to compile and run. Again, I can press F for the full screen, and if I zoom in with my EasyCam, you can see this, and there's my field of dots. It's a little dark on the screen here because the dots are very, very small. One thing that I can do is it's drawing all of the points with a single pixel. But in my draw loop, I can say what point size the points would be drawn at using GL point size. And I'm going to say actually draw everything at 3 pixels, or let's make it 5 pixels. So when I'm drawing a point cloud, which won't be, the size of the dots won't be changed by distance, just drawing points in space, it'll draw them at 5 pixels. So if I compile and run this now, we'll see our mesh much more clearly. So if I press F, there's our mesh. We're looking at it flat. And if I zoom in, you can see there's the mesh. And if I tilt, cool. There is my mesh, and I can manipulate it and move it about, and I can control this with all kinds of things. And it's just showing me the vertices rendered in this mesh object. If I pause this now, what I want to do is go and join them up. I'm going to do it like we did on our fabulous drawing. So we got all the points. Now I want to turn them into triangles. So in my code, in the setup, we've got our loop where we make all our vertices and put them into the mesh. Now we've got them all. I'm going to go through the width and the height, counting through. As we draw through our loops, I'm going to say, get this point, go across one, go from one across and go down one, and then go back up. And start here all the way across. But when I get to the end, I don't want to go on, because as you can see, there's no extra point up here. So essentially, if we had a row of 10, we'd connect 0 to 1, and 1 to 10, and then 10 would link back to 0 to give us our triangle, right-handed, and then we want the left-handed one. So we say MainMesh add index x plus y times the width. So we start off, x is 0, y is 0. So we'll start off with point 0, and then we say link that next, add an index to x plus 1, and then we say add index x plus y plus 1 times the width. So it's going to go from 0 to our width, so it'll be 0.50. And then we do the same the other side, where we're effectively connecting point 1 to what would be point 11, back to point 10 to give us that other triangle. So that will give us our mesh by connecting all the indices. And what's then very, very cool, in our draw routine, now that we've got our vertices, all our points, and our indices joining them up, we can come to the draw routine, and instead of saying MainMesh draw vertices, we say MainMesh draw wireframe, compile it, run it, hit full screen. There is our beautiful mesh that I can manipulate, which is really, really cool. Now, at this point, it's a little boring, and we want to do something with it now that we've built this object. So we can change the position of all of these vertices, and the indices, the lines joining them up to make the triangles, we'll just go with it. And in the update, I'm going to say, when I press a key, I want to randomize all the Z values of each of the points. So in the XY grid, they'll stay where they are. And I'm going to do it off a key press. So in my header file, I'm going to make a Boolean called messy mesh. And when I press the M key, I want it to bounce around. And then when I press it again, I want it to stop. So I've got this Boolean, and in my key presses, if I press the space bar, take the Boolean messy mesh and make it the opposite. I'm going to initialize here, Boolean messy mesh starts out false. And in my update, I'm just going to loop through every single vertex, each point, and mess with the Z value. Here's the little routine. I'm going to say, if we press the space key and Boolean messy mesh is true, I just got this for loop, which goes from I equals 0, and MainMesh, one of the properties we can ask of it is, how many vertices have you got inside you? How many points are you made up of? We don't care where they are. We just want to mess with the Z values in them. So I say MainMesh, get the number of vertices and just loop through with I incrementing I++. And what I'm going to do is I'm going to say, make me a vector3 variable called new position at the beginning. So this will hold an X and a Y and a Z value. And I'm going to say, go to the MainMesh, please, and get me the vertex at position I. So it's going to return me this X, Y, Z value that we put in there earlier. Put it into new position. So that's now got an X, Y, and the Z value. We don't care about the X and the Y. We just want to mess with the Z value. And I'm going to say the new position Z value between -10 and +10. So we keep the X position, we keep the Y position. Now we make a new random Z position between -10 and +10. And then this vertex that we're looking at, starting out at 0 all the way through this list of the points in the mesh, we say MainMesh, set vertex. It wants to know what vertex number. But I'm just going to put new position back in, the existing X and the existing Y, but the Z value, here on line 75, we messed with the Z position. So every update loop, we're going to go through, if messy mesh is true, and mess with the Z values. Compile this, run it full screen, look at the side, and when I press the space bar, it's messing with all the Z values randomly. So it's like super crunchy between plus and -10 in the Z value, but the X and the Y position stay the same. And we can see that if I go to have a look at this from in the front, you can see, but the X and the Y positions are staying the same. And I have this fabulous kind of crunchy weirdness. So I'm going to stop that, and I'd like to be able to control the X and the Y height. Now I'm going to show you an example in a minute using a thing called Perlin Noise. At the moment we're just making noise, which is very crunchy. The one point has no relation to another because we're rolling a random number every single time. And Perlin Noise is a kind of pre-calculated randomness that gives us smooth randomness or lumpy randomness. I'm going to put some technical links in because there's quite a bit going on, named after the guy that invented it, and it's a very computationally efficient way of making kind of smooth randomness. So I'm going to play with Perlin Noise in a little bit, but first of all I'm going to make two floating points. One is Perlin height and one is Perlin range, and this allows us to control how much we're going to distort the Z values. And I'm going to start off with Perlin height to be 5. And instead of in my update saying make a random between -10 and +10, these magic numbers, I'm going to use this variable, Perlin height. So now it's going to be -5 or +5. So we use Perlin height variable, and I'm going to go again to my key control so I can increase and decrease this Z value. And in my key routine, if I press the right key, the height is going to increase by 0.1. And if I press the left key, it's going to decrease. So we've just added some key controls in. Let's compile this and run it and see what we've got. There it is. Press the space bar. Crazy. Now, if I start to decrease that value, you can see I've got this much more controllable bouncing. And at any point I press the space key and it stops it, but it'll just stop updating the values in my indices. So the distortion that I made to that mesh in the Z values, and here you can see very clearly all the X and the Y values are the same. The Z values stay the same. So I can switch it on, switch it off. Kind of neat. What I want to show you now is how we can do a much more interesting distortion using Perlin Noise. Perlin Noise, as I said, is a way of getting kind of smoothish randomness. And there's one-dimensional, a two-dimensional, and a three-dimensional Perlin Noise. So it's either a line that's going up and down, or a surface, or a three-dimensional volume that's randomized. I want to be able to switch between showing this wireframe bouncy rendering and the Perlin noise. My Boolean in my header, I'm going to add another one, Perlin mesh. When I switch this on, I say, draw me a Perlin influence mesh. When I switch it off, stop. Just draw me a plain mesh. And in my setup, you can see where this is going. I set Perlin mesh. So initially it'll just draw my gridded mesh with the randomness. And in my update, if I press the spacebar and messy mesh becomes true, I do this messing with the Z value and it all bounces around. I press the B key, flip the Boolean Perlin mesh, and in my update, I'm going to say if Perlin mesh Boolean is true, like I press the P key, I want to do the same. I'm going to go through, just like I did with this random Z value, I'm going to loop through every position in my vertices, each one in this MainMesh object, and I'm going to count through the X and the Y, but I'm going to keep count of which vertex we're looking at in our big list by having this extra I. So I make an integer called I, and then I go into my X loop, which is inside my Y loop. Get me the position X and Y and Z in a vector 3 of whatever vertex is at I. So it'll start out at 0 and 1 and 2 and 3, 4, count through all the vertices in our mesh, put it into new position. And then I'm going to use our friendly map function. So I can give it a value, give it a range that I want that value to be between, and tell it to remap it to another set of values. The function that I'm going to use to get Perlin noise is awesome. It's really simple. It's ofNoise. And I'm going to put a link here in my video, down here, I'm guessing. Go and read the documentation about it. But basically, I can give ofNoise a value, and it will return me a random value between 0 and 1. And if I ask it for 2D Perlin noise by supplying 2 coordinates, it'll return me 2D Perlin noise, which is what I want. So I'm going to supply it 2 values. One is here, inside this map statement, and then the next one is here. Because if I have my grid of points that are all triangulated, I have my mesh. This point I want to smoothly transition to this point, but I also want it to smoothly transition to this point. So we need to know in a 2-dimensional grid of noise what's going to influence what. So we're going to provide the Perlin noise with 2 values, and it's going to give us values back. So I'm going to say get X as we go across, and X using the OF map, X is going to go 0, 1, 2, 3, 4, 4, all the way to width, and it can be between 0 and width, and I want it to be mapped to between 0 and the Perlin range, and I'm going to change this value Perlin range, and it's a parameter that you can put into Perlin noise that changes how lumpy it is. It either is very smooth, or when we have a higher value in Perlin range, it gets quite jagged. And you'll see this in a minute. And I've set this Perlin range variable you saw just now. And then I'm going to do the same for my second value, supplying the Y value, which can go between 0 and height in our map function. 0 and Perlin range is what we want to come back. And then I want to multiply whatever comes back from the ofNoise function, which will give us 1 value, which we're going to use for the Z. Previously, we were just rolling a random value, and this time I'm going to multiply it by the Perlin height. So as I use the left and right keys to increase or decrease the Perlin height, it's going to change the height of our Z distortion. Then I'm just going to say MainMesh, set the vertex at position I, which we're looking at to be this new position XYZ. So long-winded explanation, but basically we're doing the same as before. We grab the XYZ position of any individual vertex in our mesh. And in this, we, rather just using random, we use ofNoise, the Perlin Noise function, to get a new height. And as we're traversing through, it'll be randomized, but it'll be smooth between them. So I'm going to compile this, and when I press the P key, it should flip between. Here's my mesh, and if I press the P key, I should have Perlin Noise. Now, you can see it's kind of curvy, and the up and the down key will increase the Perlin range, and this increases the complexity of the Perlin Noise. And you can see as I'm pressing the up key, we're getting this much crunchier kind of noise, which is random-ish, but it's sort of smooth. So I get this very different effect, which is very, very nice. And if I press the down key, you see it simplifies and I get a much simpler mesh. And if I use the left and the right key, before it was changing the amount of randomness that we had vertically, this is just amplifying, so the mesh lumps will get steeper or taller. And if I decrease it, you'll see that they get smoother, which is really, really beautiful. I've done this before. A couple of years ago, did a demo basically using very similar code, but I've added a couple of things to it. What I want to do now is go, this is great, but what does it look like as a point cloud? Because I think point clouds are just really cool. Wireframes, point clouds, crunchy, dirty electronica. I like it. Melodic, decorative, not so much. Back to my header file, more booleans. I'm going to set a new boolean called draw wireframe, which means if it's true, draw me a wireframe. If it's not, draw me a point cloud, please. I'm going to set up at the top here in my setup, draw wireframe initially to be true. And then scrolling down in my key pressed routine, my switch statements are awesome and are really your friend. I'm going to say if I press the W key, just swap. Draw wireframe, don't draw wireframe, one or the other. Then all I need to do, knowing that I've got the vertices and the indices, and I've got this ability to press the P key and turn it into Perlin mesh, or press the spacebar, make it randomize, all I need to do is in the draw routine say, if draw wireframe is true, draw wireframe. Otherwise, draw vertices. Which is kind of nice. So I'll tidy this code up just to indent it all. So now I'm going to compile this and run it. And off a couple of simple keys, we've made a mesh very simply. So I've got my mesh. I can look at it. I can manipulate it. I can randomize it. And I can increase and decrease the height of my randomization. I can also press the P key and get it to be Perlin Noise, which I can increase the complexity of, and I can increase the height that I'm rendering it at. And if I press my W key, I can now render this as a point cloud. Which is kind of beautiful. And I can do exactly the same if I press P off and render my messy mesh either as a wireframe or point cloud. Now, I'm going to come to the Perlin mesh and do two more little things before I finish up. This is really nice, and what I love is where I'm increasing and decreasing the values, it moves about, but I'd like it to do that automatically. So what I can do, if I finish this and come to my code, in the update routine, where I'm setting the Perlin mesh, I'm going to make a new floating point variable called time and get the system milliseconds and divide it by 100.0. So I have a floating point value that's slowly increasing. And because when we ask Perlin Noise for a particular value, it always gives the same one back, if we increase slowly what we're asking, it'll change smoothly the value that it's giving us back. So when I ask for a Perlin Noise, an ofNoise value, I'm going to say, give me x plus time. So it's going to be asking for x, and then it's always going to be increasing a little bit, frame by frame. So now, and I render my Perlin Noise, it's going to be slowly changing the value that it's asking for using the ofNoise function, which means it's going to distort, animating beautifully like this. And now I can increase the height of these waves by changing the Perlin height that I'm multiplying my Z distortion by. And I can increase and decrease the complexity of the Perlin noise by changing the Perlin range that I'm asking for. So I can make it very, very smooth. Or if I increase Perlin range, you'll see not only have I got quite a lot of height, I can increase the complexity of the distortion that's happening, and with the W key I can change this into rendering a point cloud, just drawing the vertices for me, which is just fantastic. There's two more things I'm going to do, and then we're wrapped up. One is it would be great to be able to mess around with the color. I can set the color at each of the vertices, but what I'd like is to be able to change the color based upon the height, so I could have it looking like contour maps on land or waves. So the bottom of the wave is a dark blue and the top of the wave is white. Where I'm setting up my Perlin noise distortion by height, I can just say, give me the height and map the Z value height of the wave from dark blue to something else. So in the middle of my, if we're looking at the Perlin mesh, I'm going to say, make a new OF color, called new color. The code for this is all online. And then here, set this new color using HSB, hue, saturation, brightness, which we've seen before in a bunch of different videos. I'll put some links. So we can set the hue and then the saturation and the brightness. I'm going to say, set the hue to be 150, which is a kind of bluish color. And then I'm going to start out with 255, full saturation, and then take away the height, which means that if it's not very high, we're not taking away very much, it's going to be very saturated. If it is quite high, the Z value is going to be bigger, and we'll take that away from 255, so it'll be less saturated at the top. Based upon the Z position, and then using the map function, we're going to map it so that even as I increase the height of the waves, the white will always be here and the blue will be here, or the white will be here and the blue will be here, and it'll map the range between the two. So I'm saying, get me the Z position, map it between 0 and whatever our value in Perlin height is, as we're using the up and down key, and map that from 0 to 255, and at the end, set the brightness to be 255. And then I just say, get that color, new color that we've set, and set vertex I to be that color. That being the plan. I can see the color has changed. And if I increase the height and the complexity, I can see the valleys of the waves, this darker blue, and the tops of the waves coming through. And if I increase this even more, we'll see it better with some more complexity. The waves coming through are less saturated and pale. And if I press the W key and tell this to draw a wireframe, it works even better. So there I've got my beautiful, beautiful changing mesh with the color points. To make it look even better, I can come in and increase the point size and it looks even better. So in my draw routine, I'm using GL point size, tell that to be 10. And I'm going to come up to my mesh width and height and tell it to be 100 points by 100 points. We could go more. Let's go more. 500 points by 500 points. So we've got now 2,500 vertices in this. And there's my mesh. You can see it's made of lots more points. And if I look at it as all the dots, you can see there's my dots. Move it to be a Perlin mesh. And as a wireframe, you can see I've got this huge mesh now, 10 times, well actually 10 by 10, so 100 times bigger. There's my mesh, beautifully flowing away, and you can see it changing color of the vertices based upon the Z value as it flows through. And if I move it from wireframe, yes, that's beautiful. And you could go through and you could put your own colors in, you could change the algorithms, change the height. Instead of having it using time to move in the X direction, you could have time to move in the Y direction, or you could make it circular, all kinds of different things. You could make it respond to mouse controls, and all sorts of stuff. And there, I think we're going to stop there. There's a bunch more things that I wanted to do, where we take the random Z distortion, and instead of doing every point random, we make the first line random and we move it back, and that marches, and then we make the next line random and move it back. In fact, I can show you that now. I'm going to uncomment the code. It's in the setup. If you like, mail me, leave a comment, and I'll do more like this. I'm going to do this last bit and then wrap up. So I thought that would be really nice to take my messy mesh and turn it into a random terrain. So I wrote a new routine called March Mesh, and I set up a Boolean for March Mesh, and in the setup I said that the March Mesh is false, and in my key press routine I said if I press M I want the mesh to march away from me. And I'm going to comment all of this out. And basically what I do is I go through each line of the vertices and copy it back one. And when I get all the way to the front of the mesh, I make a new line in randomness. So it's only the front edge that's being randomized. And then the next time I go through the loop, I copy those values back and back and back and back and back. And also I added in the new color set by HSB height. So when I'm randomizing, it's also going to do this distortion of blue to white. You could add in your own colors. So now, let's see what we got. All of the source code is available online. The link is down below. Leave comments and let me know what's going on. So I can run this full screen. And there's my mesh. And if I press the space key, it's going to randomize it. There you can see it's my blue mesh and it's randomizing. And if I press M to march, I've got my mesh, and it's only randomizing this front edge, and it's pushing all of the other values one at a time, row by row backwards. And if I decrease the height a little bit, using the up and down keys, there. to my randomized mesh, and I can go to my Perlin Noise and distort that. Render it as points. Increase the complexity of it. And there we have it. I think we're going to stop right there. If you like the video, please hit the like button, subscribe, because that's the thing that makes me happy, actually, stupidly. Leave comments below. You can get all of the source code from the link down below. Show me what you're doing. I'd really love to see. Tell me what you want to see in future videos, and I will see you on the next openFrameworks superBasics video. Thank you very much.